Okay, good morning. So let us continue the lesson. Last time we learned, so our goal last time was to learn how to solve this differential equation, yes? So let me just summarize briefly. So we wanted to solve this differential equation. One method that we actually we've learned a general method to solve the problem in its full generality, and that was multiplying both sides by an integrating factor. The integrating factor, we learned that this is e to the power of ax, so we multiply both sides by e to the power ax. And then what happens, the left-hand side becomes the derivative of a product, and that product is e to the power of axy. On the right-hand side, I have e to the power of ax f of x. Then I ask myself, I need a function whose derivative is that function. So this function is a primitive function for that. I also introduced the symbol, which is very similar to an integral symbol, but without these limits, and we call it a primitive function of this function. But of course, we should also add a constant at the end. And then we want to find y, so y becomes, I have to divide everything by e to power ax, which becomes e to power minus, let me write it up there. So this becomes y equals to e to the power of minus ax integral from of the function this dx, and then I have c e to the power of minus ax. So this is the general formula, like a general formula that you can use to solve these equations no matter what f of x is. Exactly like that, you have an ABC formula for quadratic equations. So whenever you see that you have a quadratic equation, you read the coefficients a, b, and c and put them in the formula, find the answer. Here you have a differential equation, a is given, f of x is given, and then you have this general formula. But the obstacle in front of us for using this formula is because usually answering this question is not that trivial. Okay, so if I want to find a primitive function for this combination, sometimes this is even impossible, or it is really time consuming. Okay, this is not given in your book, but I just want you to know that with the same trick, you can solve the problem in its full generality. So this is why we become motivated to find an alternative method if possible. And that alternative method is under this title, the method of undetermined coefficients. Of course, it has its own limitations. It only works if this f of x on the right-hand side is of particular form. So these three forms that we want to discuss, one of them, f of x being a polynomial. So let me write, this method works so here we don't have any limitations. The only limitation is from our own ignorance. Sometimes we cannot calculate this. But here, the method itself has some intrinsic limitations, and that is we cannot solve it for any given function, but we can solve it for a variety of functions under these titles. So this method works only if, number one, f of x is a polynomial. Number two, f of x is an exponential. Function. Number three, f of x is a sine, a slash cosine, or a combination function. Okay, so under these three possibilities, which is the only one you need to learn, we can use this method, okay? And I don't know if you remember, I gave you an example of a function f of x to be a polynomial. So it doesn't hurt if I start with a little bit simple problem like that before. So let us say I want to solve this differential equation. Okay, let me also talk a little bit about the theory. So you know that if you want to solve this equation using this method, the general idea is to solve the problem, solve the homogeneous one, okay, and find the general solution. This we already answered. So the general solution of the homogeneous one, let me call it y sub h. We learned that this becomes a constant e to the power of minus ax, okay? And then for the second one, instead of finding the general solution, I just need to find a particular solution, okay? If I can manage to find this, then we learn that if I add the general solution of the homogeneous one to the particular solution of the non-homogeneous one, what I get is the general solution of my equation that I am interested in. We also prove that why this is true, okay? So this is the general solution of the equation y prime plus ay equals to f of x, okay? This one is a particular solution of the same equation. And as you see, this is the general solution to y prime plus ay equals to 0, which of course is always and always this one. Okay, so if I want to describe this method for you. So let me start with an example. Let us say that I want to solve this equation. I want to solve this equation. If I want to solve this equation, I can of course use my general formula, but let us see what happens. Okay, so let me write method 1. The general solution. Using the general solution. Solution, let me give it a name. General solution, or general formula, sorry, not general solution, general formula. And then let me give this a star. So we can use this immediately. I want you to feel why this is not expressed in your book, okay? So if I want to use this general formula, I can immediately solve the problem. So I would write y is equal to e to the power of minus ax. A is minus 2, so minus ax becomes e to the power of 2x. Then I have integral. Integral here means a primitive function of e to the power of ax, which is e to the power of minus 2x, multiplied by f of x, which is 5x. So I can put 5 out, but I have to write x inside. And then I have dx. Okay, we don't need to put brackets, but let me emphasize that this is one expression. And then I have c times e to the power of minus ax, which is 2x. And more or less I am done, except at the high school level, you in principle don't know how to calculate a primitive function for this. So let us say you know that, If you know that, you calculate this, put it here, you have your general formula. So you really don't need to do something more. Okay, so, but because even if I know how to calculate this, if it becomes a little bit more complicated, I myself prefer not to use the general formula, but to use the method of undetermined coefficient. Because even if you know how to solve this in general is a very lengthy calculation. Okay, so this is why even if you know how to do it, it's still good to know this method, alternative method as well. Okay, so this is one method finished. Okay, but now what is in your book is not this method, is method number 2. Okay, let me write method of undetermined coefficients, MUC for short. This is in the book. Okay, so let me give this a name here, method of undetermined coefficients, okay? Okay, so now what is the point? If you want to use this method, you have to divide your problem into 2 problems. One problem is the homogeneous corresponding equation, which is very simple to write. You just need to write 0 on the right, whatever is there. And then find the general solution of that, which you have it in the formula sheet, which is the one that I wrote on top there. Yes, that's always the case. So if you want to find the general solution of this homogeneous equation, this is the answer. So I would write that, okay, y sub h is equal to a constant multiplied by e to the power of minus a, which is positive 2x. And then keep it. And then you need to look at this given equation, but you don't need to find the general solution. You just need to find one solution that works, okay? You want to find yp. The method of undetermined coefficient works in this stage, yes? You need to use the method of undetermined coefficients to find that. Okay, your goal is to find a function that satisfies this equation. For example, it is a combination of guesswork and analytic work. Yeah? So you want to guess somehow what type of function have a chance to be a solution, and then try to fine-tune it in a way that it really works. For example, if you want to find, by just guesswork, a solution to this one, I hope that you agree with me, it is pointless to try sine and cosine functions. Yes? Because if I try sine or cosine, then the derivative of sine and cosine is again sine or cosine. So here on the left, I will have a combination of sine and cosine. So I will not have a chance to reach to 5x. So thinking about sine cosine function is useless. Yes? Is it good to think about logarithmic functions? No, because the derivative of logarithmic functions is, for example, the derivative of ln of x is 1 over x. And it will not be 5 times x or something, because in 5x you have x in the numerator, but 1 over x, the x is in the denominator. Yes? And so what is the best thing comes to mind? If you want to guess a function, what type of function you will guess here? Yes, Aaron?
A polynomial.
A polynomial, yes. Because if you have a polynomial, its derivative is still a polynomial, and the left-hand side is a combination of 2 polynomials. It has at least a chance to be a polynomial, because 5x is also a polynomial. But do you think it is plausible to think about a polynomial of degree 5? No, because if I have a polynomial of degree 5, its derivative is a polynomial of degree 4. And the left-hand side becomes a polynomial of degree 4. The right-hand side is a polynomial of degree 1. So we can even narrow it down more, yes? So what type of polynomial do you expect has a good chance to be a solution for this differential equation?
Of first degree.
A polynomial of degree 1, yes? But a polynomial of degree 1, how many of them are there? Infinitely many. So I have ax, so let me not write a. So m and n. Yes? So this might have a chance to be a solution of this differential equation, because if I put this here, 2 times that is still a first degree polynomial, and the derivative of that, it becomes just a number. So I have a number and a degree 1 polynomial combined together. It still has the chance to be 5x. Of course, I have to fine tune m and n in a way that it works. So this is why I'm saying that method of undetermined coefficients is a mixture of guesswork and analytic work. The guesswork was this, to guess that it should be a polynomial, but the analytic work is to fine-tune m and n so that it fits. How can I fine-tune them? It's very simple. This is supposed to be the answer to this differential equation, so it means it fits the equation. Yes? So this means that if I replace y prime with yp, y with yp, I expect that this works. Let us see if I can't find such an answer, such an answer. So what should I do? I differentiate yp, which is just m, minus 2 times I put yp here, and then I want to fine-tune m and n in a way that the left-hand side becomes identical to the right-hand side. Can I do that? So I multiply this by minus 2, so it's minus 2mx. I write m here and minus 2n here. Okay? It is 5x. So now my question is that, can I fine-tune m and n in a way that the left-hand side becomes identical to the right-hand side? Of course, one possibility is to choose minus 2m to be 5, so that this becomes exactly this, and choose n in a way that this becomes 0, yes? So if I can find m and n in this way, then I am done. And it is possible. Because, for example, if I want to find m is minus 5 over 2. If I put it here, so n is m divided by 2, which is minus 5 over 4 now. So I found m, I found n, I put it back here, so I have my particular solution. So it's minus 5 over 2, x minus 5 over 4. This is my particular solution. Yes. Okay, now what do I have? This, I need to use this idea. So if I want to find the general solution of my equation, I need to find the general solution of the homogeneous part, which I did here. And I need to just find one answer to my problem, which I did here. And the only thing that I need to now is to combine these, yes? So the answer to this problem is y is equal, sometimes people write y of x because that's a function. It becomes the general solution that you see here is c e to the power of 2x, but I also add this part to it. So this is the method of undetermined coefficients. Yes. So if you want to solve that differential equation, you split it into 2 parts, the homogeneous part, which you have the formula for it in the formula sheet, and the non-homogeneous part. But for the non-homogeneous part, by a mixture of guesswork and analytic work, you should be able to find that one. And it will not work unless the right-hand side is a polynomial or an exponential or a sine cosine function, because these are the functions, these are the only functions that derivatives behave in a structured way. If I have a very complicated function, when I differentiate it, it becomes totally a completely different function. But if I have a polynomial function, when I differentiate it, it is still a polynomial. If I have sine or cosine, if I differentiate them, one of them will change to the other one. So it is predictable, yes? And if I have an exponential function, it mainly repeats itself. But if I have a combination of strange functions, multiply together, divided by each other. When I differentiate it, there is no foreseen pattern, so what will happen? So that's why we cannot solve those problems if we have different functions. Okay, let me give you another example. I will give you another example for which f of x is an exponential function. For this, except this one, exceptionally, you can always use the general formula, and that is at the level of your lesson, even though it is not in the book. So let me solve it in two different ways again. So number 2. So this is the first example today. So let me write it as, okay, so let us put a constant here, 5y prime plus 10y. Let me write it as 20 e to the power of minus 7x. Okay, if you don't mind, let me make it just 2. Because 20, I will simplify everything by 5, okay? Here, if you want to solve that differential equation, for the general method, so let me solve it again in two different ways. In the previous case, I was not able to finalize it. Do you remember? I wrote it. It's not wrong, but this is beyond the scope of the high school studies, so I just stopped there. So it's not complete yet. But in this case, I really can complete it if I want to use the general formula. Okay, so again, what you need to do, so let me write method 1. Using the general formula, using star again. Okay. So what can I do? But be careful. Even if you want to use this general formula is found under this condition that this coefficient is 1. Okay, so let me emphasize here. So this formula in the formula sheet that you have, and even this formula that you don't have it, they only work if this coefficient is 1. Okay? So if that coefficient is not 1, you have to make it 1 yourself first. Okay? So we go back here. So what can I do now? I divide everything by 5. So this becomes y prime plus 2y equals to 2/5 e to the power of minus 7x. Okay, and then let us assume that this formula, you know about it, you put everything here. So y becomes what? What do I have? I have e to the power of minus ax. Here a is positive 2. So this becomes e to the power of minus 2x integral. What do I have? I have e to the power of positive ax, which is e to the power of 2x, multiplied by e to the power of minus 7x. Why? Because I have to multiply it by my f of x. Sorry, I made a mistake. This is not my f of x. I have a 2/5, so if you don't mind, let me pull 2/5 out. So this one and that one is just this f of x, and then I have dx, and then I have a constant e to the power of minus ax, which is e to the power of minus 2x. Okay, now you see that this is at the high school level, yes? Because these two can be combined into one exponential function now. So that is one kind of exception here. This 2/5, e to the power of minus 2x, and then here you write integral. So if I have these two multiplied with the same base, I write the base, I add the exponent, so it becomes minus 5x dx, and then I have my constant c e to the power of minus 2x. But then, because of this coincidence that they can combine into one function, if I ask you, do you know how to calculate it using math for knowledge, you will answer yes. But the answer to this is a primitive function for that. What is this one? So it is 2/5 e to the power of minus 2x, copy and paste so far. And then what is the answer to this? I need a function whose derivative is e to the power of minus 5x. That's a famous one. What's that? Minus 1/5 e to the power of minus 5x. So what you see here was the answer to this part. And then the rest of the story. So plus c e to the power of minus 2x. And of course, I can simplify this a little bit more. 2 over 5 times minus 1 over 5. So let me write the answer here. So it is y equals to minus 2 over 25. Yes? And then I have e to the power of minus 5x times e to the power of minus 2x. It becomes e to the power of minus 7x, but plus a constant e to the power of minus 2x. So this, if you want, you can do it like this, but this is not in your book. I'm just telling you that if the right-hand side is an exponential function, calculating this one is at the right level of your lesson. But you don't need to learn it if you don't like it. Because this formula is not in the formula sheet. Really? No, because that is, I told you, this is not in the book. Okay, but now the one that is in the book and you have to learn it is the method of undetermined coefficients. Okay? So let me now clean this and then try to repeat the process. So what you do, okay, so what you do here, you divide the problem, your problem, into two parts. Okay? Remember, I want to solve this after this coefficient is 1. So I have two problems to solve. One, the homogeneous part, which on the right-hand side I have 0. And one, the problem itself, but not all solutions. I just need to find one particular solution. That's enough. For this one, you have a formula in the book, in the a formula sheet, and that is y sub h, which is a constant c e to the power of minus ax. Yes? Now, for this one, you just need to look for y sub p. Again, the same idea. You are trying to have a mixture of guesswork and analytic work. So in this case, do you think it is reasonable to look among polynomial functions here? No, because if I have a polynomial function, this becomes a polynomial, that's a polynomial. If I combine them, it becomes a polynomial on the left, but I have an exponential on the right. So it is not reasonable to have this guess. Is it reasonable to have sine and cosine? No. So is it reasonable for you? Okay. But is it reasonable for you to have an exponential function? But how many exponential functions we have? Infinitely many, but there are 2 degrees of freedom again. So if I ask you, what can I write for an exponential function? You write e, and then you can write a constant a here and a constant b up there. So that is an exponential. Okay? But even without starting the problem, this b is more or less a unique value. Can I choose b to be 6, for example? No, because if I have b6, then y prime becomes a multiple of e to power 6x. And this is also e to power 6x. If I combine them, there is no way for me to get e to the power of minus 7x. So it is not very natural to start with all guesses. What is the most natural guess for b? Minus 7. But still, I might not be able to guess the correct value for a. So up to here is guesswork. The rest of it is analytic work. So you have to be able to find a. So what can I do? Again, this is my rough guess. Not rough guess, it's probably an educated guess. That's not so rough. So I put it back here, yes? So I put it back here, y prime. So this is, sorry, let me write y sub p. So I put it here. It becomes a e to the power of minus 7x prime plus 2 times a e to the power of minus 7x. And on the right-hand side, I have 2/5 e to the power of minus 7x. And try to calculate as much as you can so that you can compare the left and the right. So what happens here? Minus 7 goes down, and the function repeats itself. Here, 2 times a e to the power of minus 7x. And on the right-hand side, I have 2/5 e to the power of minus 7x. And now if you see, I can combine them into one term. It's minus 5ae to the power of minus 7x. And on the right, I have 2/5 e to the power of minus 7x. But the guessing becomes extremely simple now, yes? This means that whatever this number is, in order to have this equality valid for all choices, this number should match with that number. So this part is analytic work. It was not that easy to be able to guess what A is from the beginning. So this means that minus 5a is equal to 2 over 5. So what is A? Is minus 2 over 25. And then you put it back here. Then you have your particular solution. And then what happens? You write your general solution. And I hope that you see that would be the same thing that we got there. So if I want to write the general solution, what is the general solution? Y is equal to always. Y is YH plus YP. So YH is here. YP is this one. And then you hopefully see that this is exactly the same thing. Of course, the other order, it doesn't matter. Yes. So this is one of those exceptions that you can go a little bit beyond high school. Yes. But again, I said what you need to learn is only method 2. Okay. Any questions here? Yes?
Are we allowed to use method 1 if we can simplify?
Yes, yes. Yeah, don't worry about it.
We're not allowed to write just like with the integral. We have to be able to simplify it completely.
Yes, yes.
Okay.
Yeah. What's your question? The same? Okay. Okay, so let us now go to another example. Okay, what do you expect me to write down now? An example of which type? Sine and cosine. Yes, good. Okay, let me write another equation. Y prime, let me make it, I just keep it 1. But remember, if it is not 1, you have to divide by that coefficient first, okay? So plus, let me write it 2, y equals to 5 sine 3x. So we want to solve this differential equation. Okay, if you don't mind, let us skip method 1, because in method 1, what happens, you have to write this e to the power of 2x. This is one of those ones that you know how to calculate if you study a little bit higher mathematics. So it is not useful for you now, okay? Because you need to multiply everything you remember by e to the power of 2x. So you should be able to give me a function whose derivative is this. You should be able to find a primitive function for this function. You will learn how to do it in university, but not now. It's a little bit more complicated. Even guessing is not that easy. Do you remember Aaron was able to guess for x e to the power of ex? So he was able to guess a function whose primitive function, this one. But for this one, it's more complicated, I think so. I don't think you can immediately find a function whose derivative is this. And if you want to find it, the method is called method of integration by parts. Okay? Anyway, so we just go directly to method 2. But let us just review again. So what is the method? The method means that, okay, you divide your problem into 2 problems. One problem, the homogeneous one, which you know how to solve it immediately. What's the answer? Is ce to the power of minus ax. It's very simple. And then you need to find a particular solution for this. A particular solution. Okay, again, a combination of guesswork and analytic work. What type of functions do you expect? Do you expect that it's a good choice to choose polynomial function here? No. Exponential function? No. Logarithmic function? No. So what are the functions that you might choose? Sine and cosine. Okay, that's a good question. Now, that's a good choice. But sine or cosine finally, or a combination of them. Because if you choose sine, its derivative becomes cosine. And then you, on the left, you have a mixture of sine, cosine. If you choose cosine, its derivative becomes sine. Again, you have a mixture of sine and cosine. So, what do you think we will do? I just want you to understand, okay, I will clean what I will write now, but I want you to understand, for example, which one do you want to choose? So you, okay, mixture is the correct answer. But let us say that you just don't want to choose for some reason a mixture. Okay, so you choose, for example, sine. By the way, what do you think I will put for the argument here? Because I can have sine 1x, I can have sine 3x, I can have sine 2x, which is more plausible here? 3x. 3x, because, yeah, 3x is the best choice. I hope that you agree with me. But then, I need to put a constant here as well. So I need to find this constant. But then you will see that I will be in trouble. So let us say you just put sine 3x, because you see on the right you have sine. It is natural to start with a sine only. But when you put it here, you differentiate this function, the derivative of cosine, sine becomes cosine 3x, yes? And then you have to multiply by the derivative of this, which becomes 3, and you have an a here reserved, so it becomes 3a cosine 3x. And then you copy and paste this one, which becomes what? 2a sine 3x. And then you want to force it to become equal to sine 3x, but this is not possible. Yes? Because if you want to force the left-hand side to be equal to the right-hand side, you have to get rid of this cosine. And the only way that you can get rid of the cosine is to choose a to be 0. But unfortunately, when you choose a to be 0, you also get rid of sine, which you don't want to, because the left-hand side becomes 0. So that's why I want you to feel that if you just choose 3 sine x, even though it is natural guess, but it has its own limitations, and that is the limitation. Yes, is that clear? Or either you should give up, or you need to find a way. Okay? Because probably we are humans, we don't want to give up. Yes? That's the whole meaning of life. Yes, we have to. If we give up, we will die. Okay? So what we should do now? As you said, a mixture of sine and cosine. But what type of mixture do you expect? Because, so you might say that this is also a mixture of sine and cosine. I agree with you. That's a mixture of sine and cosine. But do you think it's plausible?
No.
No, because if I put it here and differentiate it, it becomes the product rule. It gives me 2 more mixtures, and that's already a mixture. So if I add them, it becomes a mixture of sine and cosine, but I don't have a mixture of sine and cosine there.
Yeah.
So this mixture is not good. Which mixture do you like?
Does it have anything to do with trigonometric data? So sine squared.
No, sine squared is not a good choice. I want to have 3x here. Because I hope that you agree that 3x was natural. There is no way for me to start thinking about sine x. Because if I differentiate it, it becomes sine or cosine x, but I want to have a 3x. So it is reasonable to start with this one. And because of, I hope that I could convince you that only sine or only cosine will not work, so I need a mixture. And I told you, is this a good mixture? You answered correctly, no. So I'm asking you, what is a good mixture now?
How about dividing?
Dividing is also the same problem. Because if you divide, what happens? If you put it here, you have to use the even worse formula, the quotient rule, which is more complicated. Okay? So what is the one?
You add.
Add. Yes? Okay. But adding is also not that good like this. Because there is nothing to... If you might be very lucky that what you write here works. But in general, you need to have some degrees of freedom to be able to fix them. Undetermined coefficients. What do you think I will write finally?
A sine 3x plus a cosine
3x.
No, because if you write A and A, you are forcing the A's to be the same.
B.
But there is no guarantee, so let us write B. That's the correct combination. Yes? So this is your educated guess. But still there are two coefficients left unknown, and that is why it is called undetermined coefficient. The method of undetermined coefficient. So now everything is ready. So let us just try to put it here. So this becomes A sine 3x plus B cosine 3x, and then I have a prime, and then I have plus 2A sine 3x plus B cosine 3x is equal to 5 sine 3x. Yes? And let us try to do some computation. So here, what is the derivative? The chain rule tells me that 3 goes out, so it becomes 3a cosine 3x. And here it becomes minus 3b sine 3x. If I'm making a mistake, please let me know. And then I multiply 2 in, so 2a sine 3x plus 2b cosine 3x. And on the right-hand side, I have only one term. Yes? Okay. Can you tell me what will be the next step that I will do? Okay, but no, yes, that's the goal. But how should I get rid of cosine? For example, it is not a good idea, because one way of getting rid of cosine is to choose b0 and to choose a0. But that's not a good thing, because if I choose b and a both equal to 0, then unfortunately these good things also disappear. So even though it might be reasonable, but it's not working. So what should I do now?
You can choose A and B, so their difference is 0.
Okay, so what is the best way to think about it, if this is a little bit complicated?
3a cosine 3x plus 2 cosine.
Yes, you factor this out, yes? And then you factor this out. So between these two, I can say 3a plus 2b, and then I have cosine 3x. And between these two, I can write plus minus 3b plus 2a sine 3x. Yes? And then I demand that the left-hand side becomes equal to the right-hand side for all choices of x. Now I can do it. Yes? Because I demand this coefficient to be 0 to get rid of cosine that I don't need, and make this one equal to what? 5. And then hopefully I can solve the problem, because I have 2 unknowns and 2 equations. So this is the hardest part. So for the polynomial part, you could solve it more or less easily. For exponential function, you can solve it, but for trigonometric functions, including only sine and cosine, I hope that you agree the tangent is not working like this. I want to ask your opinion about tangent as well. So here, I have to make this 3a plus 2b equal to 0, and I have to make minus 3b plus 2a equals to 5. And you see that even though you could guess, but it is but it is hard just be able to guess a and b in a correct way. But here I am not guessing anymore. So that's a combination of guesswork and analytic work. So I want to solve the system. For example, how should I solve the system? For example, you can find b from this equation. So it's minus 3 over 2a. And then I put it in this equation. So it becomes positive 9 over 2a plus 2a is equal to 5. I multiply everything by 2. 4 and 9 becomes 13. A is equal to 10. So a becomes 10 over 13. Which was not that easy to guess. And then I put it back into this equation. I multiply everything by minus 3 over 2. So it's minus 30 over 26. Yes? And then everything is ready. So if I ask you what is your particular solution, you will tell me my particular solution is this. A is that number. Yes?
Can't you simplify A and B?
Can I?
You can simplify B.
Yes, B I can simplify, thank you. So this becomes 15 over 13. Yes. Okay, and then what is y of p? A is 10 over 13. sine 3x, and then you have minus 15 over 13 cosine 3x. So that is also your particular solution. And then what you need to do, you need to write the answer, which is y is the sum of the general solution that you have here and this particular solution. So this becomes c e to the power of minus 2x plus 10 over 13 sine 3x, and then I have minus 15 over 13 cosine 3x. So it's a little bit complicated solution. Yes? Okay. Let me give you one more example of this, but let me change a little bit the nature of it. So do you remember the initial value problem? Initial value problem was a differential equation with one more condition in your case, so that you can fine-tune this left constant there. Yes? That's called an initial value problem. So let me just do it, but let me give you an example of this type, because I think the previous types were not that hard. Of course, we can practice more, but this is more or less the lesson we want to finalize. Okay, so let me give you this example. Solve the following initial value problem, okay? Initial value problem, okay, for short. And the problem is this. So they give you an equation, so let us say y prime plus, let me write it, minus 3y equals to, on the right hand side, I will write 2 sine x, let me write it 5x minus 3 cosine 5x. And then when you see that this is an initial value problem, you need that something is coming. And let us say that y at pi over 5, or let us make it pi over 15, is equal to 3. So what does it mean? It means that you can ignore this condition for the time being and solve this problem. You will get an answer similar to this, in which a constant is not known, and then you use this extra piece of information to find that constant. So even if you see initial value problem, you can momentarily ignore about this and do whatever you did before. Okay, but let us try to do that, okay? So what we should do, we need to split our problem into two problems, yes? One of them is y prime minus 3y equals to 0, which we immediately know. YH is CE to the power of minus a, which is positive 3x. And then I need to consider about a particular solution of this differential equation. Only one is enough for me. Okay, so now instead of this question mark, you should have some educated guess. But I think now you have a little bit more experience, even though this is a little bit more involved. Don't think that this becomes too involved because I have two of them. You will see that's not the case. It's more or less the same length. So what is your educated guess for y sub p, if you understand what's going on? Yeah?
would be the same as the last one.
Yeah, even though I have both of them on the right, I hope that if you think a little bit, you will understand that I need again both combinations. So, but which argument? Just 5x. So, what can I guess for this? Again, a sine 5x plus b cosine 5x. And then I put it in my differential equation. Okay, so what we do, we just write a sine 5x plus b cosine 5x prime is minus 3 times a sine 5x plus b cosine 5x is equal to this. Yes? Okay, let us just do it. I think differentiation is simple for you, so let me just do it fast. And then I multiply this in. Okay. Now I hope that you have some experience from the previous one. What I'm supposed to do on the left now? Factoring. Factoring between this and that, I factor cosine 5x out. And then factoring between this and that, I will have minus 5b minus 3a sine 5x. On the right hand side, I see the combination 2 sine 5x minus 3 cosine 5x. And then you want to fine tune a and b so that the left hand side becomes identical as the right hand side. But still the problem is simple. What you need to do? This is the coefficient of cosine. The coefficient of cosine is minus 3. And this is the coefficient of sine. The coefficient of sine is 2. So they have to match. Yes? So this means that 5a minus 3b is equal to minus 3, and minus 5b minus 3a is equal to 2. And then again, you solve the system. I don't know how do you want to solve it. For example, let me multiply this by 3. Let me multiply this by 5. Yes? If I multiply the 1 by 3, it becomes 15a minus 9b is equal to minus 9. If I multiply this by 5, it's minus 25b minus 15a is equal to 10. And if I add these two, this minus 15a and 15a are gone, so it becomes minus 34b. And on the right-hand side, I will have just 1. And b finally becomes minus 1 over 34. And when b is found, I put it either here or there to find my a. So let us put it here, for example. Okay, let us use the first one. I have 5a minus 3 times my b, which is positive 3 over 34, is equal to what? Is equal to minus 3. So I move this to the other side. Minus 3 over 34, which is what? So 5a is equal to minus 3 times that is 102 minus 105, yes? Divided by 34. Am I right? Yes. And then a, I have to divide by 5, so I prefer to divide this by 5. So it becomes minus 21 divided by 34. Yes? This is just simple algebra. And then yp is equal to, what was my yp? It was a times sine phi x. This is minus 21 over 34 sine 5x Yes. And then plus b, which is minus 1 over 34 cosine 5x. So that is my general solution. Oh, sorry, my particular solution. So the general solution is YH, you see here. I actually gave you a very stupid number anyway. So 3x, and then plus my particular solution. Okay, so this is your general solution, but still now this last piece of information becomes relevant. I need to find this c, and that's why they provided us with an extra piece of information, and they haven't asked you to solve the differential equation, they have asked you to solve the following initial value problem. Yes? Okay, so what we to do, I need to replace x with pi over 15. I expect to get 3. Yes? So what I do, instead of y, which is my output, I put 3. Instead of x everywhere, I put pi over 15. So c is still not known. E to the power of 3 times x, 3 times 5, let me do it in our head. So multiply this by 3, which becomes pi over 5. Yes? And then what do you have? You have minus 21 over 34 sine of 5 times x, which is 5 times pi over 15, which is pi over 3, and then minus 1 over 34, and then you have cosine pi over 3. Yes? And then you have to solve this. I didn't see that this is going to happen, but this is possible, yes? So, because sine pi over 3 is a little bit nasty number, but this one is more or less good. Okay? And this we don't even bother to calculate, e to the power of 5, pi over 5. Of course, if you want approximation, you can do it, but you just leave it as exact. So this means that 3 is equal to, if you don't mind, let me bring these two terms to the right-hand side. So it becomes positive 21 over 21 square root of 3 over 68. I multiplied these things and brought this to the left. I multiply, I bring it to the left, is equal to c e to the power of pi over 5. Okay? I don't know, if you want, we can take the common denominator. So I have here 21 square root of 3, and then I multiply this by 3, what is that, 180, 204, yes, 205, yeah. Yes, and then I have that one equals, then I divide everything by e to the power of 5 pi, pi over 5, so this is my c. Yes. So what I did, this is just a bad example probably, because now you are confused with numbers. But numbers, forget about the numbers, yes? It is just a number, that's a number. I multiplied square root of 3 over 2 by that. This becomes 21 square root of 3 over 68. It was negative, I moved it to the left, it becomes positive. It becomes minus 1 over 68, I moved it to the other side, it becomes positive. Then if I haven't done any mistakes, I just calculated that. The denominator is 68, times that is 204. And then plus 1 is 205. So this is why I have 205. But then I want to make c alone. So I have to get rid of this factor. So this is why I divided everything by that factor, that's my c. But what you need to write as the answer, it's a little bit painful, but you have to write this, put it back here and give it as the answer. So the y is 21 square root of 3 plus 205 over 68 e to the power of pi over 5, yes, e to the power of 3x minus 2134 sine 5x minus 1 over 34 cosine 5x. Okay, so this is your solution.
How did you calculate 68 times 3 so fast?
Oh, that's not hard. I always care about money, yes? So if you want to borrow me 3 times 68, you can immediately calculate. You give it me if I ask you for 300 crowns. Yes, 3 times 60 is 180.
Yeah.
3 times 8 is 24. Add
Oh,
them.
you add that, but you did that like in half a second.
Okay, so it's not something. Have you seen this German guy? I will show you, by the way. It's astonishing. You cannot even believe the brain, you can do the calculation in the brain. So if you're a little bit tired, let us just look at it. Yes. Okay, so if I give you this simple equation y prime plus y, but then I would put here x plus e to power 2x. Now, do you think the method of undetermined coefficient works for this case as well?
Yes.
Yeah. Because now, if I gave you this, if I have given you this, you know how to solve it. If I have given you this alone, you know how to solve it. But let us add them together. But there is no particular function that serves like this. If you choose a polynomial function for your educated guess, it remains a polynomial. It will not generate a polynomial cross exponential. And on the other hand, if you choose an exponential, it will generate only an exponential and it will ignore the polynomial part. Okay? But let us ask you, do you have any opinion we can solve it using the undetermined coefficient method? So you will again hopefully tell me that I need to find the general solution of the homogeneous part, which I always have the general solution. In this case, a is 1, so it's minus x. So that's it. Pardon? Yeah. And I make this very simple because my goal is to teach you something else. Okay, so if I have this one, if you don't mind, let me give coefficients as well, okay? Something like that. Okay, now, for the second part, you remember you have to write your equation, but you are looking for a particular solution. Again, the topic is the same, so you should have an educated guess, a mixture of guess and analytic work. But I hope that you feel the difference, yes? Because in this case, you knew what to do. Your educated guess would be among polynomials. But if I gave you this, you knew that your educated guess would be among exponentials. But now, if you just say polynomials, there is no way for you to generate this combination. And if you say only exponential, there is no way for you to generate this combination. So what do you think will be how we can go out of this problem?
A combination of both. So
Okay, I can test what your idea, because I want you to discover it yourself. Okay, so what do you think? What would be your educated guess?
maybe under ax plus b, ax plus.
So you see, first you concentrate on this part, and you say that what is working for this is a first degree polynomial. So it means that it is reasonable to have this in my function, but I also need something to fix this part for me.
e to 2x.
So e to the plus e to the power of 2x. But do you think that you also need a coefficient there?
E.
B is already reserved there, so you should write C. So let us put little c. Yes, and because this C and this C are very close, so let me use alpha, beta, and gamma. Yes. So let us see if it works or not. So that is the whole power. So you don't need the best guess. You need one guess which works. That's the whole point of the particular solution. Okay, let us see if it works or not. If I put it here, what happens? This becomes alpha x plus beta, and then plus gamma e to the power of 2x prime. And then instead of y, I have to repeat everything. Alpha x plus beta plus gamma e to the power of 2x. And then on the right-hand side, it becomes 2x plus 3e to the power of 2x. Okay? And let me do the calculation. The calculation is extremely simple. Alpha x derivative becomes alpha. The derivative beta is 0. Here 2 goes down, and the function repeats itself. Yes? And here nothing. I just copy and paste everything. And you know the goal. Your goal is to find one guess that works. You don't need the best solution, you just need one solution that you are sure it works. I hope that you agree with me that let us write this in a form which is similar to what we have there, yes? So let me write alpha x first, and then alpha plus beta are alone, so let me write them here. And then I have 2 gamma e to power 2x plus another gamma e to power x becomes 3 gamma e to the power of 2x. This is what I get on the left. And on the right, I will have 2x plus 3e to the power of 2x. So what happens now? I want to fine-tune alpha, beta, and gamma so that the left-hand side is guaranteed to be equal to the right-hand side. So what do you choose for alpha? 2. Because here the coefficient of x is alpha, the coefficient of x there is 2. So it is natural to choose alpha to be 2. And then what do you choose for alpha plus beta?
Sum is 0.
The sum should be 0 because there are no constant terms there. Yes, if it was 5, you choose it 5. But there is 0, so alpha plus beta should be 0. And what do you choose for gamma? So 3 gamma is equal to 3. So if I can find these constants, then I am done. And it is possible because alpha is already determined. Beta and alpha are supposed to add to 0, so beta is -2 and gamma is 1. So it means that my particular solution is 2x minus 2 plus e to the power of 2x. This is your particular solution. And the general solution, let me write it here. So what's the general solution? The general solution is the homogeneous part, which is ce to the power of minus x plus what you see here. It's e to the power of 2x plus 2x minus 2. Yes? Is that clear?
Why did you do the method of the beta in the first place?
No, because if it was here, yes, so you need to consider the most general first degree polynomial. The most general degree is not this one, it's alpha x plus beta. Yes, you have to consider the most general case. Of course, if you are lucky, in this case, you see, in this case, beta was -2. In case that beta is 0 and you guess it wrongly, it will not hurt. But in this case, it becomes problematic. Okay, any questions? Okay, the battery is dead now, but I will probably speak a little bit louder. But let me make it a little bit more interesting. What do you think if I multiply them? Do you think the same idea will still work? So what is my question is this: if I give you the same problem, y prime plus y, but instead of adding a polynomial to an exponential, so let us say, for example, I multiply them. Yes? So what do you think I will do? I will not change, of course, the homogeneous part. It is exactly the same, but my goal is to, what is your intuition? I don't know. It's you should also develop some intuition. Yes. So what do you think is a good educated guess for this problem? Because in that case, I added a polynomial to an exponential, and what Aaron mentioned worked very fine. And then, of course, you have this recipe that you can add. You can imagine they are individual, and what you guess for the one, you write it down, and then you think, okay, I have another one, so let's add that one. So that's a good recipe for that. But what do you think about this situation?
Is it ax times e to the power of 2x plus a constant t?
No, it's close. Yeah?
Could you do alpha x plus beta times gamma?
Yeah, and this turns out to be the good conjecture. And by the way, the person who actually designed these methods, they actually did some trial and error, realized it works, then we are following that person. So that's something like this. Not everything should be crystal clear from the beginning. You have to sometimes do some trial and error. And of course it works. So what you said, I will write this one, so sorry, beta, and then e to the power of gamma x. So you were actually telling yourself that, okay, this is sitting for that, this is sitting for this, and for the case of addition it worked, my conjecture, so let me try to see if I am so lucky that it still works for the product. Okay, and then you see that it works. Let us see, by the way, if I remember. So what should we do? Of course, the differentiation is a little bit more involved here. So this is the product rule now. Yes. So if you want to calculate y prime of p, which is the derivative of the first one multiplied by the second one, which becomes alpha e to the power of gamma x, and then plus the first one multiplied by the derivative of the second one, which is alpha x plus beta. Gamma comes down and the function repeats itself. So this is y prime. Okay? So now, if you don't mind, let me factor e to the power of alpha x out, gamma x out. Then I will have alpha plus gamma times this, which is alpha gamma x plus beta gamma. So this is my first derivative. And I put everything back into my equation. This is my gamma, this is my y prime. So this becomes alpha plus alpha gamma x plus beta gamma. And to be honest, I am not...
Why didn't you have gamma in the first place? Why not?
Gamma.
yes, you are right. Why did I put gamma? So this was 2. Yeah. So everywhere I see gamma, I put 2. Yes. And I think it's not working. Let me see.
Why doesn't e to the 2x have gamma as a coefficient?
No, because when you differentiate, 2 goes down. Yes. Yes. So this should go down. So but gamma is 2. Sorry. Yes. Thank you. Okay. So let me see if it works or not. Yeah, it seems it's working. Okay, so now we have that, and then I write everything here. So instead of y prime, I put this expression, so alpha plus 2 alpha x plus 2 beta.
Hey, Baba, didn't you forget a 2 in the e to the power of x?
Here?
Yeah.
Yes. Yes. Thank you. Yes, everything is fine. Okay, so I put it there. It becomes that one, e to the power of 2x, and then plus y, but this is my y. And this is supposed to be x e to the power of 2x. Okay, now you see why it works, yes? Because now I can factor e to power 2x out, and then I have x e to the power of 2x here. And what is left for me here? I have 2 alpha x here, which will be added by alpha x. It becomes 3 alpha x. And then I have 2 beta plus beta is 3 beta. And I also have 1 alpha left here. And I want to fine-tune alpha and beta in a way that these two match. E to the power of 2x part are already the same. So I need to force alpha and beta. I need to fine-tune alpha and beta so that this becomes x. Yes, but that's also easy. 3 alpha should be 1. Then it guarantees this is x, which I need. But I also have to guarantee that this is 0. Yes, because I do not have any constants sitting here. Okay, and then you solve that one. So alpha becomes a third. You put it here, beta becomes minus 1 over 9. And then you put them back there, so yp is equal to 1/3 x minus 1 over 9, and then e to the power of 2x. So that is your particular solution. But you don't need to be worried about these things in the exam. So you don't have it. So you have, I don't think you have a mixture. In case you see a problem in the book, a mixture, this is the method that you need to use. Okay?
What was the method? It seems like guessing to me.
Yeah, that is the...
Get one particular.
Yeah, that's what I told you. That method of undetermined coefficients is a mixture of guesswork and educated guess. Educated guess and some analytic work. Even though I was able to get this reasonably, but it was not possible for me to exactly find alpha and beta. So that is, I told you in the beginning, undetermined coefficients is a mixture of guesswork and
analytic work, but which will work. And this is why you understand that if I take this one and put tangent x, so you immediately realize that the method of undetermined coefficients is not useful at all. Because then you need to ask yourself, what type of function I expect so that this combination gives me tangent, yes? This is why it is not. The reason that this method works for these functions because the derivative of polynomials, exponentials, and sine and cosine act predictably. So you know what happens if I differentiate them a lot. But for the other functions, we don't know, yes? So, yeah. Any questions? No? Thank you.
Thank you.